now we're going to construct the angle bisector of angle A. If you notice, the construction marks in this diagram are showing us that angle B has been bisected. These two marks were equidistant from B, and they were used to make these marks. And then the same thing happened on angle C. So we have just one angle bisector left to construct, and then we can see the concurrence of the angle bisectors. So to bisect an angle, we have to just put the bullseye of the compass on the vertex, and we draw our first arc. Then we're going to measure from the one point to the other point that we just created, and we draw our arc on the inside of the angle, and then we flip it around and we do the same thing from the other point. Once we do that, we're going to line up the vertex and the intersection point, and when you do that, you should see it goes right through the intersection. It's mine slightly off, but it's going right through. It should go right through. If you do it extremely accurately, and I must have moved the compass slightly, it will go right through that point. And that point is called the incenter. And that point is always equidistant from each side of the triangle. Now, this is a little harder to demonstrate than the last one, because in order to find the actual distance to the sides, the distance to the sides has to be the perpendicular distance to the side, which I'm not going to construct because it's going to get messy. But I can approximate it. And so that point that I just created, the incenter, is going to be the center of a circle that just sort of skims the edge of the triangle. So it is, yeah, this is a little bit, it's a little off, but that's just, I didn't measure it accurately. So, but you can imagine that it would fit a circle inside this triangle, just touching the edges of the triangle.